In zones of rifting continental plates, the crust is pulled apart. The brittle crust yields by fracturing along a fault. Faulting is accompanied by a slipping motion along the fault plane. Along the steeply inclined fault plane, the crust on one side is upthrown relative to the other, leaving a cliff called a fault scarp. Normal faults are not isolated features. Grand-scale, normal faulting can produce tilted block mountains. Commonly, multiple parallel faults occur, giving rise to a particular pattern of rock structure and topography. A narrow block elevated between two normal faults is a HORST. A narrow block dropped down between two normal faults is a graben. Grabens make topographic trenches that form wide valleys surrounded by mountains carved from HORSTs. Some of the world's deepest lakes are water-filled grabens. When continents collide, sediment layers are compressed. The rocks suddenly yield to the compressional movement. In a reverse fault, one side rides up the fault plane over the other side. This leaves an overhanging scarp that produces landslides. The overthrust fault is also a compressional feature when one slice of rock slides over another on a low-angle fault plane surface. The thrust plane rides over the ground surface. These sheets may be up to 50 kilometers, or about 30 miles wide, and may carry for many tens of kilometers or miles over the underlying rock. One type of lithospheric plate boundary is where one plate slides past another. This is called a transcurrent or strike-slip fault. The rock masses move in a horizontal direction past one another. There is little or no vertical displacement along the fault. Only a thin fault line or narrow trench marks the rift zone. Transcurrent faults can become locked. That is, the rocks on the two sides do not slip by one another, although the lithospheric plates continue to move and exert shear force. A sudden release of accumulated strain may produce a major earthquake.